Alright, welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. And, well, before we jump back into code, maybe it would be a good opportunity to check some of the new conversations that are here waiting to be answered. Menu improvements master topic. Let's see. What is new here? Ah. Here's the output. Extract all the colors. Okay, there's some odd colors in here. If a color in general is defined as X, its equivalent in 0 hour could be determined based on the existing blue-white palette and through calculated adjustments. For instance, the orange text in general currently maps to white in 0 hour, but it might work better as blue, provided we verify screen contrast and readability. Yeah. Progress and findings. Colorless simplifications. I started by removing colors with no visual impact, such as colors with very close values. 000,255 is black. Yeah. Colors like that, which have 0 alpha and don't display on the screen. Yeah. I also replaced all instances of this with 0, which resulted in... Oof. I don't know if that is really necessary to like edit all the colors. Just leave the original ones, because then you get this huge diff between original and new one for no big reason. Missing colors and image-based elements. I noticed that the brown color of the slider and the blue color of the slider blocks are not defined in the file. The brown color does not appear at all in the color list. The blue slider blocks appear unrelated to the blue colors in the list. This suggests that similar to button frames, combo box frames, and text box frames, the slider might be composed of small image elements. Yeah, I agree. These are probably small images in one of these TGA files, SCM shell, whatever. Untraceable colors in combo box. Another interesting case is a white text inside the combo box, which remains unaffected even after removing all white colors from the file. The white text inside the combo box, which remains unaffected even after removing all white colors from the file. This indicates that the white text is not defined in the color list and might be influenced by another source similar to the brown color of the slider. White text inside the combo box. Huh. After filtering out non-displayed and unrelated colors, here's the resulting list. Okay, this screen is probably from like hovering buttons, and you see this lime text. This is probably like the outlines of the elements, some blue tones, some gray, okay, white. I mean, it's a pretty simple color palette. All right. Would appreciate any thoughts or insights, especially regarding where additional default colors might be defined. The palette mapping. Yeah. He did have a, he did make a nice, I thought he did make a post in the Discord server. I don't know why he did not post that in the, yeah, maybe perhaps I suggest to make this also part of the GitHub conversation. Okay, so back to the topic. So projects, generals, files, art, textures. Okay, we're looking at SCM or something like this. SC. Maybe not. Data, English, art, textures, user interface. Here are the most of the elements. Which one is it? SCSM, this one. Many of the elements are inside data, English, art, textures. Yeah. So these are most of the elements. Many of the UI elements are inside. Okay, so his question, untraceable colors. White text inside comment which remains unaffected even after removing all white colors from the file. In the worst case, the white color is hard coded in executable. Well, hopefully it's not the case. Actually, hold on. Isn't there also like an ini file? There is an ini file with in-game UI. This one. Good. So there are some colors, message color. So, well, so there are a bunch of white fonts here, or white colors, let's say. But maybe they don't relate to combo box. But maybe they do somehow. Right. Okay. We need to make the reply here. Okay, many of the UI elements are inside this. Many of the UI elements are inside. So here we can say perhaps font color is taken from somewhat in this file. In the worst case, the white color is hard-coded in the executable somewhere. Okay, is there any other UI file here? Don't think so. I think this in-game UI is the only one. Well, there's also game data in here. Like this could perhaps contain some font stuff. Here's some colors. Shroud color. I think what we can also say is we can also dig in Thyme to see where combo box color might come from. I think combo box is implemented. In the worst case, the white color is hard-coded in the executable. Good. So I hope that answers it. Color list simplification. Colors now such as colors like have now 0 alpha. Yeah. I suggest doing this doing this in temporary edits. For now. So it's doing this only in temporary edits for now. It creates a huge diff to the original for no big gain. Only for research edits for now. It creates a huge diff to the original. Missing colors and image-based elements. Yeah. So are these blocks in here? Yeah, so here we have a gray. It could be this one here. And the other one here. Yeah, that here are the elements. Yeah. It is definitely inside. Okay. I noticed that not the brown blocker not defined in the file. The blue slider blocks appear unrelated. Yeah. Untraceable colors. Final cleaned up list. Yeah. But it could be beneficial if we are convinced that this avoids noise and we do not need the avoids noise, do not need the original unseen color values. Well, let's say, are we convinced that these changes would not bite us later somehow? Are they for research purposes only, or do you like this to be merged into mainline, into main branch? Okay, so here's my revised proposal regarding colors. I based my approach on how the colors were applied in Generals 1. In the regular state, the text color was similar to the background color of the highlighted state, but slightly lighter. For the highlighted button, the text color matched the middle shade of the button's border. Similarly, I've defined the colors for 0 hour 2, though I haven't yet finalized the text color for the regular state. In my view, option 4 appears to be most suitable as it aligns with the color of the checkbox. Please see the example below. But it can be argued that the regular state in option 4 is still too dark and will be difficult to read. The regular state, this one. So this highlighted is irregular. Let's can we open this? Oh, there's some error. Copy image. New. Okay, let's zoom in here. Okay, so this is generals, which is a nice color scheme, and this is the original 0 hour, right? Did he use JPEG compression, or what is this? It's a PNG, okay. That's good. Okay, so. Okay, what I can already say is I do like the highlight here on the top. This is better than here, because here the highlight is on the side, which looks shady. This looks pretty dark. Let's see the luminance values. So here we have this orange and we have this orange here, right? So this, or yellow. So this one has luminance 82. 82, and the other one 54. 82, 54. So let's see. So 82, 54 for generals, yeah? Generals. Okay, and then 0 hour we have the original 0 hour. We have luminance 100, that's a white, it's 100 luminance. And the lime is 93. So this is highlights, and this is defaults. So 0 hour has highlights 93 and default 100. So it actually gets darker as you highlight it. And so this proposal here, this one, there we have this and this. So here 43 is the base. Let's call this original. 0 hour original. So this is 0 hour. Let's do 1, 2, 0 hour, edited 4. So this one has 43 for this color, defaults 43, and the highlighted is 76. 76. Okay, so it is darker than the original, but it's also darker than generals original. So maybe, yeah, it's hard. The problem is blue. Blue is a low luminance color compared to green and red. So like if we look here, we go to blue, you see the luminance is 31. Whereas if we look at, so wait, let's do here 0. So this is just 100% blue, luminance is 30. If we go to A green is luminance 88, so that's pretty bright. And red is also respectable, somewhere sitting in between red and blue with 54. Right? So red and green have more luminance than blue. Blue is a really dark base color. So it's one of the reasons why this is so dark, because just blue is that dark to begin with. Which makes it hard to work with here. Yeah. 43. This is definitely too dark. This is bright, but yeah, it's white. Cloud shadows. Yeah. The gold orange, certainly it gives more clarity. It gives more opportunities to make bright things. Yeah. I don't like this. I certainly don't like this. The original has a problem that you have this lime color and it's sitting there on the blue. It's kind of weird, but we got used to it, right? So for us, it probably doesn't look weird. For people who have been playing 0 Hour for 20 years, it doesn't look weird because they got used to this, but it is weird in a way. So if you look at the generals, this one has a much better color scheme. Because here, this text, this font has the same color as this background. And here the highlighted except has the same color as the border. Right? You see that there's logic behind this. Whereas here, well, except is just white because all other text is white. And here you have a lime text, which doesn't make any sense. Right? So, yeah. It has but you can say, okay, it has its unique color scheme. It doesn't need to follow this color scheme. But the question is this a good color scheme? It is a bit more clinical than this one. Right? Okay, here are the luminance values of the fonts. The main problem the problem I see here is that blue color comes with the disadvantage of low luminance. Which is a major disadvantage over green and reds, or greens and reds. I do not have a good idea right now. I think it is worthwhile to experiment more. Worthwhile to experiment more and try to find a color composition that looks nice. It would be good to at least hit luminance levels of generals. Ideally exceed them because the original 0 hour colors are much brighter. 0 hour fonts, whites. Looks nice. And yeah. Okay, I think we are done here for now. Okay, let's take a look at local comment fixes. Okay, so basically we look at what are we looking at? Let's start from the bottom. Strength sentence was correct about strength. Remove sentence about strength. Okay. Fixed. Resolve conversation. Is this the latest change? Well, it still shows as a div here. It somehow still shows as a div. Let me see. It's a website text to character codes. UTF-8 text. Okay, what happens if we just copy this symbol? Copy. We can't. Okay, it's not a symbol. Let me see. This is a symbol. Here's a space. So this is not a space. It's something else. If we paste it here into Notepad++, I can't paste it. This is not a character. What is this thing? It says span class. What is this? Huh? Is this just a bug inside? Maybe it's just a bug inside this viewer here. This looks really strange. So here's this text, and then the string ends, and then there's a span here where this is, and then the exclamation mark comes, and then a dot, and this, yeah. So somehow, what is this? Use $0 in the console to refer to this element. Can we... So this is line 343. Let's make a copy of this. Let's go to view file. Let's close this here. View raw. Okay, and then we search for this text. There we go. Okay, let's copy this guy. And paste it here. And it shows as space now. Seems to be a space. Or is it not? Probably is a space. Yeah, okay, let's say seems to be a bug in this GitHub viewer. GitHub. Okay, resolve. Good. Hold on. Yeah. Okay. We just assume that this is fine. Message to user when they set a bookmark. Right. Da, da, da. Da, da, da. I'm just scrolling to find comments. Okay, resolve. Perhaps do not remove the old precedes. That precedes. Yeah, okay. I think this is misleading in ways. It kind of implies that Ru is a reference language, but US is the reference language. I suggest to reword this. It's not clear how it would be helpful to me, for example, because I would use US and DES reference. Use Google Translate to translate words and sentences in Google Word document to check if your new sentences are grammatically correct. The US language is the main reference language for all other languages on which you need to base your edits and translations. But if you are unsure what is the correct meaning of US text line, please refer to RuLine. You can translate it to your language in Google Translate and you will get a better understanding of what US text line truly means. Okay, I still don't agree with this, because why would the RU line explain the US line better? Like you could make the same argument for any other language, like maybe the DE line explains it better, or the ES line, or the Chinese, right? I don't know, but it's okay. It doesn't matter much. Good. All right, so was there anything else? Okay, let's see. Shortens. Okay, resolve. Okay, shorten. Okay. All right. All right. Okay, so here should be spaces instead of tabs. Several times in this file. Skirmish. Okay, so let's see. Yeah, seems to be okay now. Yeah. Seems to be okay. We can also double check here and search for tab. So we make a tab here. We have a tab character. Let's see if we make any hits. Oh, we do. Oh, it finds it as space. Okay, that's not a good search. Let's stop the search. Oh boy, stop it. Okay, so somehow we cannot search for tab here on this. Let's make a copy of this whole file. Let's paste it here. Let's search here for tab. T. No, nothing found. That's good. Okay. Looks okay. Looks okay now. Good. Then yeah, I would only say put back the old Polish comment there, and then I think this is fine. Okay. What else? Update generals str. Oof. time. 50 minutes. Okay, let's that's enough for the review for now, I would say. Let's get back to code. Okay. Good. Then let's get back to the code and continue our stick string effort. So essentially, auto str. Yeah. So we want to get rid of these guys. Evaluate exe file name. So, sorry, this is always used as for temporary strings here. All right. Yeah. Okay. Can load exe, evaluate exe file name, like this, for example. Here we allocate strings just to check if it's empty, right? It's quite wasteful. Okay, so this auto str. Good. So string exe file name. Okay, so what kind of stack size would we settle on for this? 1024 seems to be a bit much, no? So here we can do this. Yeah. Well, I'd probably look at like a stack string 256 maybe. 256. Is max pass portable? Oof, pass max. That's big. Wow. Okay, I think we can just use an artificial limit, like 256, I think is. Yeah. Let's go with let's go in our comment types. Let's put let's put a pass string. Pass string. Let's go with just 260, which is the let's go with 260. Let's just go with 260. Optimized for Windows OS. I don't know if that makes sense. Maybe we just use our stack string all the way, yeah. But I mean, short exe name. Here we have an allocation, don't we? Oh boy. maybe we leave it for now. It's probably a bit more hassle. Okay, so, but let's see if we can still find some obvious ones that need some fixing. I mean, this is quite an obvious one. Yeah. Let's see, what else do we have here? Let's search for FMT format in here. Okay, so okay, so this one looks like something we can optimize here. We can put a stack string in. I guess 60, 32, 64, 60, 64 maybe. Thirty-two, 64, 32. I can probably go with 32 here. And we do assign format overlay. Ta-da. This one. Okay. And that's it. Okay, what else do we have here? Okay, here we got another one. Okay, this one, let's do stack string and let's do 48 overlay. Util assign formats. Okay. There we go. Ta-da. Okay. Okay, what else do we have? Okay, that's it. Good. Let's search on a more broader scale here, FMT format. There's not much left here. Here we have some. ASM instruction text. Instruction roundings and operands. Mm-hmm. Mm. Okay, but this is like a code path that we don't hit often, so it doesn't matter. Okay, what about this one here? Uh, this one, there should be return value optimization for this. Yeah. I think this one is fine. Okay. Label. M label. M label. What is M label? String label. List item UI info. Okay. Yeah. This also looks fine to me. Yeah, this is okay. Okay. Yeah, so we have a lot of allocations here. So every frame, there will be allocations. So that's not ideal, but yeah. I don't think it's worth the effort right now to make these stack strings. It's not easy to do. Yeah. Okay, I think we got the most important places covered with our optimization. So it's probably good enough. Let's see. So we have this guy here. Actually, before we do this, how about we first do all the string view changes? Yeah, okay. Let's get all the string view ones first. Because those are easier. So, ta-da. Hold on. Yeah. Okay, so this one is good. String views, yeah. Yeah. Okay. Okay. Options, string view, string view. Here we have a std string. Get config file name. Let's see. Get config file name. Yeah. Oops. Where are we? Yeah. Okay, I guess this is fine. This is fine. This is... This is fine. Here is this one here. I wonder if we should create a macro. Define. I think in this case a macro is okay. We say define to, well, let's say printf string. Let's say, yeah, printf string. We pass a string, call it just str, and then it will pass this here, printf string. And then we go to this function here. And so what we could write now is printf string that no? Oh, that, which arguably is a bit easier to look at. Expands to static cast int size, comma, str data. Yeah. I guess it's okay. Right? Like this. Let's see if it compiles. Yeah. Okay, I would say let's go with that. All right. It's maybe a little bit unconventional, but I guess it's fine. Okay, so got this. Okay. So here we got a bunch of string views. The reason I do string views is because then it allows us to also pass these text strings here, right? Which are not std strings, right? And a string view is versatile. You can pass any sort. You can pass a C string, a local array string, stack string, std string, all sorts of strings, right? That's why the stack string is like a good way to pass in something into a function, right? Okay, so I guess all these things look okay. And this also okay. And this is also all okay. Okay, here we simplified this. Yeah, I think this is all good. And we'd also take this guy. We don't take these yet. Then we take all this here, yeah. I wonder if there are some more of std string this. Yeah, options. Maybe we should also make here empty string. I wonder, is it also possible to say like this? No. Explicit. Okay. Okay, in comment types we can you can remove the vector. Okay. Stack string. Okay, I think this, yeah, so basically we just added a whole bunch of std string views. Yeah. I think there are some more of these. There's some more of these enum functions. Here, this one. So this one could also be a string view. String view, str. std string view. Dot this print f string str. Okay. Probably some more of these, no? Let's search for 2. 2. Well, let's search for const char. Const char. There we go. Okay, this one could be a string view here. Load config. No. No, maybe not. Okay, this one can be a string view. Oof, what is this here? To string. Return. SCD string view. String view. Here's another one. Okay. Here's another one. I got a lot of these guys. So here we go. Dot star. Print f string. All right. Std string view. There we go. Okay, I think that's good for starters. All right, so we got this guy, and we got this guy, and this guy. This one. Good. So printf string. Ups pass. Yeah, I think this is good. Good. Oh, hold on 1 minute. Okay. So options. Da, 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 da. C string. Yeah. Main. I hope I didn't introduce a crash anywhere. That would be not so nice. Yeah. Dot star s, text 0, text 1, text, yeah, text 0, text 1, text dot data, c not end, yeah. Good. Before we submit this, let's do one more test run. Let's see if there's no unexpected crashes or anything. Oh, we got a compiler error. Well, that's unexpected. Ah, I see. Oh, it's nice that we got a compile warning for this. Printf string. Okay, anything else? Let's see. This is weird that something is now booting slow. What is this? This hasn't been there before. Okay, that apart, that aside, this is weird. This is extremely weird. Okay, let's run this. Okay, we have a breakpoint here to see if this works. So we have a time, capacity, str, 30, written 19, resize written 19. Yeah. Yeah. Okay, and then so we have this guy and we have info, and there we have section, and somehow that didn't hit this breakpoint. Create section string. Why not? Ah, there we go. str sections. So this one gives us date.data, text unformatted section, to string view dot data. Yeah, okay. Good. Okay, so this is fast dot data. Yeah. Okay, so we got rid of a bunch of allocations. That is good. Let's also make some selections here. Let's make some selections here. Right, and things look generally Okay. Right, so yeah, I think this looks generally okay. Okay, so let's commit this stuff. So this one is um, um, change some const char and const string const std string function arguments to std string view. Change some const char and const std function arguments to std string view. Yeah, let's hope that this is all good. Good, so we commit this guy. All right, then we stash our current changes because I would like to see where this lag comes from. The sudden lag on boot, does it come from, where does this come from? Good, let's see if that compiles. It does, okay. Okay, let's see how this one launches. Okay, it also has this white. When did this start happening? Because I thought that there was no such thing. Let's go one before. Oh, how do we do that? Check out this commit. There we go. I'm confused. It also happens here. It's something makes it boot very slowly. Could it be? I have a suspicion. What could be so slow? Because we were just recently testing with all these many functions, selecting them, which then generates this huge ini file here, imgui-ini. I wonder if parsing this thing here just makes it super slow. Matched function resize. Oof. Yeah, maybe not everything should be saved. Like this is outrageously much. So I do wonder if we delete now this file and we start it again. And I just recreated it. Let's delete it again. So now let's see how fast the boot is. Aha. So it's this config file. So now the config file is super small, 1 kilobyte. And now if we compare, and now we select all here, and now we probably get a very big file. There we go. Yeah, so now the file is 2 megabytes. And now we close this. And now we launch. And now it takes a long time to load. So it looks like the loading of this file here is really inefficient. Very inefficient. Which is surprising to me because it doesn't seem so complex. It's also not that big. It should never take this long to pass. There's some severe logic issues, I would say. It takes several seconds. This is by no means appropriate for this. This should finish passing in, I would say, I don't know, 100 milliseconds max, with everything that is behind, like populating some stuff, I guess. But like multiple seconds for this doesn't feel right. No. Yeah, but maybe. Function resize. Manage function resize. Okay, but good. Anyway, it doesn't matter. Let's go back to our latest change. Checkout. Good. So stash pop. Good. Let's review our stack string changes. Good. So in function.cpp, function cpp, we have. So here we have this stuff. We can improve this by using our printf string. And we put that in here, symbol name. There we go. Okay, so here we have sub prefix. There we go. Here we have prefix off. Okay, so here we also have off. Off. Okay. Wait. Prefix off. I hope I didn't make an error. Oh, we will check. Double check. Okay, here we have unc. and that's it. Okay, then let's create here one for sub. There we go. Ta-da. Okay, prefix sub. Hold on, that is not correct. Okay, here we have another sub. All right. Good, and then we have a simple name. Simple name. All right. Good. Let's see if that compiles. All right. Good. Yeah, so here we have a stack string. That's good. Stack string n32. Let's do the simple stuff first. So this one is rather simple. Comment types. Okay, so here small string, stack string, parse string we actually didn't end up using, so let's delete that again. That's in comment types. Parse string, let's remove that. Good. Stack string. All right. Good. So util. Yeah, we spent a lot of time with this in the last session. I think we got it decently enough. It seems to work. I hope that there are no hidden bugs, but I mean, we tested this. If it works on the test cases we did, then I'm pretty sure that this is more or less okay. Yeah. What can go wrong, right? All right. Good. Here we added some stack buff. And here as well. Then here we have stack string n. Yeah, that's fine. Okay, this one is fair. This one is also buffer, size of buffer, str data, str size, written, resize written. Yeah, I think this is perfectly fair. Let's also add the to-dos here. Okay, here we have title, assign, format. This is simple enough. Yeah. Here we have auto section. Maybe this should be const. Hold on. const auto section. Yeah, guess that's fine. Good. Here we have overlay. Yeah. 48. Overlay. So this one is 33. Yeah. Let's also make this 48 then. Good, good, good. So here we have stack string buff. Yeah, stack string buff. We don't need to reserve. Yeah, we don't need to resize. Yeah, this should be fine. Wait, let me see print. Let's see where the buff is used. How do we invoke the buff? Append format buff. Oh, what do we do here? Oh, so this one is with capping, but we don't want to cap, right? Yeah, so this one is written more complicated than we need it to be. I think we can just remove this, right? Yeah, I think we just remove this. Yeah. Okay, let's search for other occurrences of buff. Buff here. Assign format. Assign format. Hold on. Okay. Buff assign. Text. Strip in place, yeah. Yeah, okay. Let me take a look at the strip in place. str, erase. Yeah, okay. Okay, and then we assign buff, and here we don't need to pass capacity. Maybe we move this here. Now on that note, since the buff is now a stack string, do we actually need to pass it at all then? Maybe we can just say create the stack string within this function, right? Like, do we really need to pass it? Maybe we just create the stack string right within here. right? But this would, yeah, yeah. Let me see. Allocate stack performance. Move the stack pointer. Single instruction. Sub ESP. Allocates those bytes. If you, yeah, we are not concerned about overusing the stack. That statement doesn't make sense. If I'm going to need some data at compile time and it's under a few hundred bytes in size, I stack allocate it. But that's not the same. Compile time and stack these are two different concepts. So this is wrong. I also don't agree with the premature optimization thing. Like, there are universal principles that they will be true. So you can write code to be performant to begin with. Of course, like, to see the real deal, you need to create the performance capture, but we are not at this point. We're still doing optimizations just because we know it will be faster. And using the stack instead of the heap, avoid allocations, it's certainly faster. So yeah, this is garbage advice. Don't listen to this. If you know that certain principles are faster, then go ahead and do it. But yeah, if you're in doubt, then verify in a profiler. That's, of course, the best. On stack took 0 seconds. On heap took 51 seconds. Okay, displays on my system when compiled with the command line. You may not agree with my approach on getting a non-optimized build. That's fine. Feel free. When I turn on optimization, I get 0 seconds. Actually instantaneous, but because any half-decent compiler can notice that on stack doesn't do anything useful, it can be optimized away. Okay, what is this? Displays. On stack took 2 seconds, on heap took this. Without optimization. Okay, what is the sample? On stack. Okay, it just puts the int I here. Delete I. Yeah. Jesus Christ. Okay, I do wonder though. Tons faster than searching a heap. Yeah. The stack string, when it's created, what does it do on construction? Here. Basic string. So there's some condition here, has lookup table, buffer. What the hell is that? Buffer. Has lookup table 2, otherwise 1. Alloc has lookup table. Set up the lookup table. Has lookup table. What does that mean? Has lookup table. Oh, why can I not search for this thing? My gosh. Current documents. It's this bullshit here. Right. Okay, so it does some things here. Oof, set up the lookup table. Oof. What is this? Lookup table view. Okay, lookup table view impl. What does this do? Jesus Christ. Oh my gosh. Okay. 2-byte span. Jesus Christ, what is this thing doing? What is this doing? As byte span, what is this? Okay, I hope that this is all just simple mumbo jumbo here. But it's really hard to say, like this lookup table thingy. It would be nice if there was a way to just disable it. Because we just want S key. Default step size 10. How do I get a 1 byte code point string? That would be the interesting question. How do I get that? 1 byte code point. Oh boy. Has lookup table. Yeah, I don't quite understand. All UTF-8, UTF-16 strings have a lookup table because they have more than one code unit per code point. If the string ends up having no multiple code units per code point, the lookup table takes only 1 byte. True, the string type has a lookup table. Value type. Is UTF-8v charty? What does it check? Is convertible. Is UTF-8 convertible? UTF chart type. Oof. So charty, UTF-8 chart type is char-AT. Aha. Aha. C50 char-AT. What is this thing here? So I wonder, can we maybe just define this guy here? Can we define this guy? Okay, to me it looks like that maybe it doesn't catch. So I think char 8T is actually available here, but somehow it doesn't get it. What is this thing here? CPP char 8T. Oh, since C++20. Okay. Oof. Oof. Is there maybe a way where we can explicitly turn off? Okay, it's kind of wild though that we have these two, but we don't have this one because it was just added in C++20. That's strange. Ah, only this thing was added. Hold on. CP. Let me. Oh no, this whole thing is since. Okay. That's a shame. Okay, so my hope is that let's go to our util. Uh, okay, where's util.h here? Okay, so I think we need to make a comment here. No, it's comment types. Comment types here. Okay, so this is UTF-8 in C++17, but ASCII in C++20. treat as ASCII. This is multi-byte in C++, 17 and beyond. Okay, let's put the same comment here. Let's simplify this to it just is. Okay, so is UTF-8 in C++7 but ASCII in C++20 treat as ASCII? Is UTF-8 in C++17 but ASCII in C++20 treat as ASCII? -1. All right. All right. Okay, so is UTF-8, maybe put a minus here, no. Is UTF-8 in C++17 but ASCII in C++20? Treat as ASCII. Okay. Good. Good. Then function. Yeah, we need to check that. But so I would like to create the stack buffer, the stack buff, where it's actually used and not before. I would just like to really make sure that it's not too expensive to create the stack string. I still fill the lookup table, upsize. I mean, there is stuff going on here. You know what would be good if we can I would like to disable this. wonder if we should make a custom change to this library and allow for a way to force ASCII string. Yeah, let's confirm. Really, I think it is a UTF-8 string, and the other one, the W string, the multi-byte string, that is a multi-byte string, not a UTF-16 string. So there's quite an inconsistency, and that's because of this bullshit macro, which caters to C++20 and not to C++17. But then they should have added an option to say, hey, give me the opportunity to just to decide for myself what I want. Do I want a UTF-8 string or just an ASCII string? And for our purposes, we would just like to have an ASCII string, right? So is UTF UTF-8 is convertible. Okay, so it's convertible. UTF-8 char type. I think it's a very bad decision to treat char as UTF-8 when by default it should not be. So I think this one should have been done differently. He should have said UTF-8 char type is void or something. I don't know. Maybe what we can do is we define this before we include this HPP. We define this question is, does he do anything else with this thing? Oof. Oh, no, he doesn't. Okay. So it's only here. Okay, that's fair. Then, oh, but then this would include this one here. This one would probably fail compiling. Ugh. Yeah. Char. Okay, let's say small, let's say let's say if small disable UTF-8, or let's say small no UTF-8, and if and then else, and then we say using shard type voids. Okay. And then we go to small no small char is not UTF-8. Let's call it's if def. Okay, and then we go to our common types here, and then we do here define small char is not UTF, and then behind it we do undef. Actually, we don't even need to undef, just like this. And the hope would be that this allows us to disable. Oh, what is this? Oh boy, we get a much compiler errors. Let's see what is the problem. Maybe void is not a good type for this. Okay, I see. This char, okay, I see. Size off, I see. Then how about we use we have to put some dummy type. I don't know, bool. I guess bool. Small char is not UTF. Bool or we just put some outrageous like uint uint 64t. Or we just put bool. How about that? Bool. I don't know if that makes sense. That's yeah, okay, that compiles. Okay, so now what should happen is I think we'll take a break. We take a break, and we got some spam here. Yeah. Spam. Yeah, we take a break, and then afterwards we test that this is now an ASCII string. And if yes, then that's good. And then I would also say we make a ticket in GitHub and suggest this, because I think it's not good that with C++ 17 and below you have no ability to decide what the char string is. Like, you cannot say I don't want UTF-8. You cannot opt out, and I think that's bad. You should have this decision to make. Yeah. So I think this is a reasonable suggestion if it works, right? Okay, so Yeah, I will take a break here. Then I wish you a great day or night. Until next time, goodbye.